Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In a universe where gravity is king, astronomers and astrophysicists imagine that gravitational collapse is fundamental in the formation of structures at all scales throughout the cosmos, including planets, stars, and galaxies. In our own solar system, we are told that a primordial cloud called a nebula collapsed gravitationally, forming the Sun and a flat disk, and it was from that disk that our Earth and all of the planets formed. This hypothesis originated in the mid-18th century, with its earliest proponents the Swedish mystic Emanuel Swedenborg and the philosopher Immanuel Kant. After more than 2 centuries, the idea had become, and today remains, the consensus theory of our solar system's formation. Of course, with exponential improvements in technology, astronomers discovered a vast cosmic landscape, including distant exoplanetary systems. It was 1/4 of a century ago that the first exoplanet was officially discovered, and in subsequent years, virtually nothing but surprises have followed. As we've reported many times previously, these exoplanetary systems have routinely defied the more than 2.5-century-old nebular hypothesis. So unexpected are these discoveries that many astronomers have wondered if our solar system is an extreme oddity, with no parallel to be found. From tight conglomerations of exoplanets packed impossibly close to their stars, to exoplanets with retrograde orbits, that is, orbits in the opposite direction of the spin of their parent stars, to tightly packed planets with radically different chemical compositions, in complete defiance of the belief that our solar system was formed from material which was graded in properties moving outward from the Sun. And perhaps most problematic of all is the discovery of numerous so-called hot Jupiters, or gas giants that orbit their relatively small stars at much too close a distance for the planets to have formed through gravitational accretion. Some of these planets have been seen to orbit their parent stars in just a few days, or even a matter of hours. This emerging crisis was acknowledged in a 2014 paper in the journal Nature, entitled Planets in Chaos. The paper states, "The discovery of thousands of star systems wildly different from our own has demolished ideas about how planets form. Astronomers are searching for a whole new theory." In the paper, astronomer Gregory Laughlin stated that the standard theory of planet formation, quote, has led to no success in predicting what is out there. Recently, scientists reported in the monthly notices of the Royal Astronomical Society the discovery of yet another theory-shattering exoplanet. As reported on phys.org on October 31st, the hot Jupiter, quote, should not exist according to planet formation theory. The website outlines the spectacular conundrum as follows. The existence of the monster planet, NGTS-1b, challenges theories of planet formation, which state that a planet of this size could not be formed around such a small star. According to these theories, small stars can readily form rocky planets, but do not gather enough material together to form Jupiter-sized planets. Incredibly, only 3% of the distance between the Earth and the Sun separates the Jupiter-sized giant from its parent star, whose mass and radius are only half that of our Sun. NGTS-1b completes an orbit around its relatively tiny parent every 2.5 Earth days. The lead author of the study, Dr. Daniel Bayliss, stated, "The discovery of NGTS-1b was a complete surprise to us. Such massive planets were not thought to exist around such small stars." But long before the discovery of any exoplanets, the basis for accepting the nebular hypothesis was highly questionable. In our own solar system, many planets present puzzles that scientists have not resolved, even after decades of study. The standard accretion model cannot explain the formation of Neptune at its extraordinary distance from the Sun. In a 2011 article in the journal Nature, the conundrum is outlined as follows. The planet is 30 times further from the Sun than is Earth. That far out, planet formation models suggest that the solar nebula, from which planets condensed during the formation of the solar system, should have been very diffuse. So scientists believe that Neptune formed closer to the Sun, where the nebula was denser, then moved outwards. But many Neptune-mass planets and other planetary systems seem to have migrated inwards rather than outwards. Equally puzzling mysteries can be found in the inner planets. In the language of Thunderbolt's chief science advisor Wal Thornhill, our planetary system is a, quote, fruit salad, filled with planets with highly varied properties, including surfaces that bear no resemblance to one another. This, of course, begs the question: if Venus, Mars, and our own Earth formed at roughly the same time, 4.5 billion years ago in the same process, why do they differ so dramatically? The planet Mars is both much smaller and drier than standard theory would predict. It should have attracted more of the lighter elements at its distance from the Sun. The planet Venus, on the other hand, has a huge amount of carbon dioxide in its atmosphere and is hot enough to melt lead. Our own Earth, on the other hand, has a huge amount of water and is obviously friendly to life. In recent years, astronomers have increasingly accepted the notion of planetary migration in our solar system. But of course, the events are placed billions of years in the past. In a 2011 NASA press release, the hypothesis is outlined as follows. Jupiter, long settled in its position as the fifth planet from our Sun, was a rolling stone in its youth. Over the eons, the giant planet roamed toward the center of the solar system and back out again, at one point moving in about as close as Mars is now. The planet's travels profoundly influenced the solar system, changing the nature of the asteroid belt and making Mars smaller than it should have been. This ad hoc theory does not explain how a Jupiter-sized planet could form at a vastly closer distance than the Earth to the Sun, to a parent star that is only half the size of our Sun. For decades, the electric universe theory has offered alternatives that resolve many of these mysteries. Neither planets nor stars form from gravitational collapse. Instead, as the electric universe explicitly predicted, it has been discovered that stars form from vast networks of filaments, like pearls on a string. Like lightning, the filaments are of a remarkably constant width, an impossible result of gravitational processes. And as the electric universe also predicts, the most prominent filaments can be seen drawing matter from networks of smaller filaments. Smaller coronal filaments are also characteristic of electrical discharges in plasma. Although telescopes can currently only pick up the largest bodies forming along these filaments, the electric universe proposes that so-called hot Jupiters can easily form along these same lightning channels. These exoplanetary systems may also affirm another aspect of the electric universe theory, as proposed by Thornhill. That is, that the gravitational force is modified by the electrical nature of any body, so that if a body is charged more or less than those around it, there will be a charge exchange, and in the process, gravity will modify the orbits of those bodies. The result is that capture is far more likely in the electric universe than in standard cosmology. The abundance of binary stars, as well as seemingly odd planetary systems, is expected in the electric universe. This includes the puzzling retrograde orbits of some exoplanets. If a body is being captured from some nearby angle, it can rotate in the opposite direction, or rotate about the poles of its adoptive star. Another serious blow to the gravitational model of star formation came in 2014, when astrophysicists obtained the most detailed images to date of a stellar nursery. They discovered that the star-forming regions, called cosmic seeds, weighed only a fraction of the predicted mass believed to be required to give birth to high-mass stars. A press release from the Harvard-Smithsonian Center for Astrophysics stated, "Previous theories proposed that high-mass stars form within very massive, isolated cores, weighing at least 100 times the mass of the Sun. These new results show that that is not the case. The data also demonstrate that massive stars aren't born alone, but in groups." This is also expected in the electric universe theory of star formation. Of course, on the vastest cosmic scales, the organizational electromagnetic force is almost immeasurably more powerful than gravity. Working scientists today now acknowledge more and more freely the complete failure of the gravitational collapse and accretion models of planet and star formation. Yet the result of this confession is the tweaking of existing models rather than exploring real alternatives. such as those which await in our electric universe. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.